Recursion versus iteration. This lecture is a comparison between recursion and iteration. Then we'll go through under what conditions, under what situations should you use a recursive approach, and under what situations should you go for an iterative approach. So if you are here searching for what is recursion or how to write a recursive algorithm, then please go to a recursion lecture. There we had explained those things. The purpose of this lecture is to understand how are recursion and iteration different, and under what situations or when to use recursion and when to use iteration. This is the main purpose of this lecture. So the first thing you have to understand is any algorithm or any problem that you can solve using recursion can be solved using iteration as well. And this also works the other way around. If you have any problem that you are solving using iteration, you can solve it using recursion as well. But this is on a theoretical side. On practical side, how difficult or how easy it is to convert recursion to iteration or iteration to recursion, this will differ from case to case on each different problem. So what is the purpose of recursion? Mainly, recursion is a way of expressing repetition. So whenever you have to do a task, again do the same task, again the same task, under these situations, recursion is a natural way of expressing this repetition. We saw this in the last lecture when we had divide and conquer algorithm. What happens there? In divide and conquer, you are dividing a larger problem into smaller problems, and the same algorithm is used for solving all the smaller problems. In such cases, recursion becomes a natural way to express this repetition. See, you can express it using iteration as well, but when you use recursion, it becomes easier for you to write the code and also easier to read the code for anyone else. So this is where we generally go into recursion. So even the sort of divide and conquer or anything that requires repetition, these can be transferred into loops or maybe explicit stack-based management. So why I said that is, how does a recursion work? If you have any recursive algorithm, how does it work? It calls a function. It will put that function into the recursive stack. And when this function is executing, it will itself call another function, which is the same function with different arguments. So when it calls the same function, it will again push the new call back to the same recursive stack. Again, this function will call the same function with new values. When it is called with the new values, what happens? Again, to the same stack, one more call gets pushed. So according to the number of recursive calls you have, that many number of entries will be pushed into the recursive stack. This is what happens when you generally run in recursion. The same thing, this can be simulated by using an explicit stack in an iterative program. So that is where I said you can easily convert any recursion to iteration, because you know recursion is working like this, where when you call the function, it is pushing it into the stack. Again, that function calls the same function. It will again push to the stack, again push to the stack, and so on. The same thing you can simulate by having an explicit stack, and in the stack, whatever is the information that is to be pushed on, you can push that information into this explicit stack. So this is a way of converting an iteration, converting a recursion to iteration. So theoretically speaking, the computational power of recursion and computational power of iteration, both are equal. This is as per theory. Both are equally powerful in terms of computation. So one question is, when should you prefer recursion? One thing is, whenever you have a problem which you want to write in a shorter algorithm. So recursive algorithms are generally shorter. One thing is, they are generally shorter. And secondly, they are intuitive. Many times when you have some logic in your mind, when you convert it into a recursive algorithm, it would look as if you actually wrote down that logic on the paper. So there is that intuitive thing inside recursive algorithms. Moreover, it generally, naturally, some problems will fit into this recursive paradigm. You would feel it when you get a bit more into algorithms. When you start working on algorithms, naturally many problems you will see that it will fit into this recursive paradigm, and it makes easier and naturally you will prefer recursion in such cases. So it increases readability, increases ease of writing the code, it will make shorter code. These are the advantages of recursion. See, these advantages would hold only for those problems which are naturally supporting this recursive paradigm. Which problems are those exact? That you will understand when you progress with this course, because we'll prefer recursion for those problems. Automatically, you will also start preferring recursion for any problem that is helpful or supportive in recursive paradigm. So this is about recursion. And when should you make use of iteration? Iteration should be used. One advantage with iteration is that it doesn't have the problem of a stack overflow. That is stack overflow due to recursive stack. In recursion, what happens is if you keep calling recursively, your recursive stack will get filled at one point and it may cause stack overflow. So if you are using iteration, there is no recursive stack at all. So you are simply iterating through the same loop. So in this case, your memory management gets easier in case of iteration. There is no recursive stack used, and in some of the algorithms, your space complexity would come down if you are using iteration. This is because when you are using iteration, you may be able to make up with that algorithm without any extra space. But the same thing when you use recursion, it will take a recursive stack and it will add up to space complexity. So in many cases, converting a recursion to iteration may help you in reducing the space complexity of your approach. So the final one-liner is, theoretically, any iterative solution can be converted to recursion. Any recursive solution can be converted to iteration. Both are possible, but the practicality of doing so, that will depend from case to case.